Good morning or good afternoon, dear students. For today's lesson, I'm going to give you an instruction of paragraph 7.2, and it has some links with chemistry because today we're going to discuss what are atoms made of and the new isotopes. And it's a new term. For most of this, what is written down over here, you already know from chemistry. Molecules are the smallest parts. At the beginning of the year, perhaps we said that they are really small, but molecules are made of atoms. So H2O consists of two atoms of hydrogen and one atom of oxygen. But what are the atoms now actually made of? Well, to understand that, you need to know this atom model from Rutherford, and it's shown over here. It's a model. In real life, they don't have these characteristics. It's a model. So in the nucleus, in the kern, in the nucleus, there are protons and neutrons, and the electrons are like a cloud surrounding the nucleus. Well, the nucleus, these are made out of even smaller particles, protons and neutrons. And these characteristics are important for physics. The number of protons is equal to the atomic number, and the atomic number is shown in the periodic table over here. So, for instance, carbon is atomic number 6, and that means it always has 6 protons in the nucleus. And neutrons and are the other particles in the nucleus, and they are more important for like gluing the atom together. So they don't have a charge. The lading is neutral, but the mass is like for gluing the atoms together. Protons, they have a mass and they have a positive charge. Electrons, they have a mass, but it's so small we can neglect it, and the charge is 1 minus. So for physics, it's quite important that an atom is always electrical neutral, and that means that the amount of protons are always the same as the amount of electrons. So let's see the periodic table. Carbon has 6 protons because its atomic number is 6, and that should mean they always have six electrons because it should be electrical neutral. Well, for now, some substances don't have enough or just too many neutrons. Because of that, they can become unstable, radioactive, and can decay. The moment they decay, they emit some radiation, and that can be alpha, that can be beta, or that can be gamma. More about that in later paragraphs, what actually alpha, beta, or gamma actually is. For now, it's important the moment they decay, dus uit elkaar vallen, it is possible they show some radiation or they emit radiation. Well, for now, we've discussed that some substances have a different amount of neutrons, and the different amount of neutrons is called an isotope. The term isotope is from, I thought it was Greek. Iso means actually equal, and top or topos is from place. So that means isotope is the equal place or the same location. So it's the same atoms, only a different mass. And that means they should have a different amount of neutrons, because here we have the periodic table, and there are some isotopes from carbon. So that means they always have 6 protons, and it's because of it's the atomic number 6. Only the mass over here it's 12, but it is possible that there are other carbon atoms with a different mass. This is the average one. For instance, an example of an isotope carbon 12 and carbon 14. C is carbon, and it's on place 6 on the periodic table. This means it has 6 protons, and because of that it has 6 electrons, electrical neutral, 6 positively charged and 6 negatively charged. The amount of protons plus the amount of neutrons are equal to the mass. Now, C12 has a mass of 12, so 12 minus 6 means it has 6 neutrons. Carbon 14 has 14 minus 6 protons equals 8 neutrons, and this one is unstable. So these two are the difference between carbon 12 and carbon 14. It has the same amount of protons, it has the same amount of electrons, but a different amount of neutrons. For now, you can answer question 13 to 17, and you can watch the other clip to check your answers. If you have any questions about isotopes or about atoms in the first place, please send me a message with Teams or Magister.